by? 21 Savage. Is Lil Yachty still a thing?
No.
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 Okay.
Besides the Sprite commercial.
Besides the
I
Sprite.
still see that once in a while on the wall.
I haven't seen that commercial in a hot minute.
I see it once in a
There's a
while.
little baby now.
He's
Little
so
baby.
good. Little baby.
Not even just
so
like
good.
Mac Miller who had the T-shirt with like the baby and the hat and
Yeah,
stuff.
It's
You guys remember Mac
little
Miller? Was
baby.
that a thing, you guys?
Kind of.
Oh, I don't
Mac
know.
Miller.
All these things.
Yeah,
Little
he's got like
baby
also
is everything but
I
good
told
and
you.
trash in person. Little baby
Okay.
is really good stuff.
So,
Yeah.
Little baby's okay.
anyway, so if we have x over x, y over y, we said, hey, x over x is going to be 1. Because anything divided by itself is 1. What is y over y going to be? Are these, and do these end up being the same?
Yeah.
Yes. Why shouldn't they be, Gracie?
Because X is not Y.
X is not y, okay. But is, we had 21 over 42 and 15 over 30. And they ended up being the same, but 21's not 15. They're both halves, but this is the same thing over the same thing, so 1. That's a good point. Abby said, hey, it's like if we put 2 over 2 and 4 over 4. I'm sorry you feel that way. Thank you. Next. Okay. So 1 equals 1. So the sides are divided proportionally. If the sides are divided proportionally, what's that tell us? Yeah, Max?
Oh,
Okay, what's the question?
you just like cross multiply and you got like x, y equals x minus.
Good question. Could we cross multiply? Yes, we can. We could get x times y to be xy. And what is x times y? Hey, look, it's xy as well. So you get the same thing.
Okay, but like you can already see that it doesn't equal. It does equal.
No, they do equal. They are.
That's what
proportional.
I'm saying. X is not. There's no way.
Okay, but if it's like 2 over 2 instead of x, and 4 over 4 instead of y, can you see that 2 over 2 and 4 over 4?
It's just very random numbers. Just placeholders.
They're just placeholders for any number. Placeholders for any, that's all a variable is. It's a placeholder for any number.
Actually, I hate that.
So that they reduce to be equal 1. 21 over 42 is not necessarily 1/2, but it reduces to 1/2, and so does 15 over 30.
Okay, but if you look at the picture, they're obviously not equal. I said that too.
No, this side does not have to be equal to this side, but this part is equal to this part, and this part is equal to this part.
Whoever made variables
Yeah, but
in math is just
But
getting
what the answer says is that each side is equal, and they're not.
No, the answer is saying the 1 equals 1. Guys, listen up, please. The 1 equals 1. What that is saying is it's not saying that the sides are the same length. That's not what it's saying at all. It's saying that they are proportional. It's saying, Tracy, thank you. It's saying that the part above this segment divided by this part below the segment is the same as this part above the segment divided by the part below the segment. It's saying the ratio is the same. The division is the same. It increases by the same amount, in this case none, and increases by the same amount from here to here, in this case none.
Okay, but the question says a student states that UV must be parallel to ST, and it's not.
Okay. UV and ST. Parallel. What's parallel mean?
They are parallel.
What's
You're
parallel
a
mean?
genius. Oh,
Parallel mean they never intersect, right? You can be confused with congruent.
Yep.
Okay. So, going back to that actually, if we use the converse of the triangle proportionality theorem, because a line divided the two sides of the triangle proportionally, we can prove these are parallel. So, do we agree? Yes, you should agree. And your reasoning could be that 1 equals 1. That could be your reasoning if you have this work. Or you could put xy is equal to xy, like Max was saying. And this could be your answer.
Max also said I don't comprehend math.
Whoa, everyone calm down. No need to be hostile to each other today.
Accurate.
Oh my god.
Did you say accurate?
I did
Yeah, we don't need to be
argue.
hostile to
I
each
did
other.
Oh, I thought you
argue.
said accurate.
No.
I'm just kidding. I'm just kidding. So
Very rude.
Thanks.
No, but-
I learned
Okay.
to travel out of
Thank you. Next. Go to the next page, please.
Okay, thank you. Yes.
Okay.
I'm so thankful for that.
No, no.
Leave.
There's so many song lyrics that
Okay.
are just all like.
Voice it back off, please. Let's try and dial it back in, guys. Let's try and dial it back in.
Oh, this is
I was gonna
awkward.
say this is the video that my other classes will see too. So.
Other classes.
Yeah.
I
So, like,
I'm telling you right now, all these problems are wrong. Listen to that.
Wait, what? Is it recording off your laptop or off that?
You guys are so annoying.
You should get
What's
a
up,
mic.
dudes?
You should get a mic that comes down the ceiling so it's better quality.
Oh,
I'll-
mercy.
I'll do it for you.
Okay, let's
I'm
go.
an audio guy.
Okay.
you?
Just get a Yeti mic.
Hi, an audio guy.
You're so funny.
Thank you, I know. Okay. Finding an unknown height. We can find an unknown height using similar triangles as well. We're going to talk about that, okay? So similar triangles, we talked about that in 4.6, is making a little bit of a comeback. Okay, don't call it a comeback, right? Okay, so
Me too.
we're going to call this method, indirect measurement.
Oh, Atlanta.
I'll never heard of that.
Nobody got room for that.
Ain't nobody got time for that.
Indirect measurement. Okay, so what we're going to say indirect measurement is that indirect measurement, it involves using the properties of similar triangles to measure heights or distances that are too great to be measured directly. So for example, it might not be incredibly easy for somebody to measure the height of, say the Empire State Building, right, in New York. Very tall building. It might not be easy for somebody to directly measure the height. You say you can do it?
Yeah, I said I could.
Okay, bet.
It's
So-
long. I just have to put my shoe up the side until I'm done, and that's how many feet tall it is.
I don't think that's how it works.
You just walk.
Because it's not. But anyway, so it might not be easy. It might not be easy for us to measure something like the Empire State Building directly by going up, having this huge long tape measure, something like that. Okay,
My feet and go like this.
there you go. Perfect. Okay, we got
Wait,
solved.
hold on.
Like that guy that did on the Trump Tower.
So,
Oh yeah.
is anyone's feet like actually as
Okay,
big as a foot?
so
Yes.
originally we got the feet measurement because some king, I think of England, said like, hey, I'm gonna call this so many feet long. It was the measure of their foot, and it happened to be what we call now our foot.
How long is his foot?
12 inches.
Oh yeah. I think mine's.
I got you.
Size.
You want to hear a cool fact?
No.
How chocolate chip cookies are made?
Yeah, do
I
it.
don't.
Yeah.
Okay, well, there was this back in the
I
day.
said no.
I said yeah.
She said yeah though.
Okay, but no.
Keep
Oh,
going.
cool, vetoed. Okay, what?
Say
Can you
it.
just measure one level and then times it?
Dana, keep going.
Okay, but what if the
Also,
levels are
you
different
get
heights?
So why would someone do that?
Maybe they have different needs for different floors, you know? Okay, some floors need to be taller than others. Okay, let's focus back on this. Let's bring it back in, focus back on this
I
class.
love how Mr. Fossil can stuff it in.
Thank you.
Chocolate chip cookies.
So, in example 1, we're going to try and figure out the height of a palm tree. My parents love palm trees, by the way. They just love them go crazy. So, we're going to try and figure the height of a palm tree. And we're going to do this. We're going to do this by measuring the tree's shadow, and at the same time of day, measure the shadow cast by a meter stick that we hold at a right angle to the ground. Okay, this is a yardstick. It's pretty close to a meter stick. It's slightly shorter, but just barely. So this is an example here.
That's 1 yard.
Yes,
You need 10 of those to get a first down.
that's
shot a
accurate.
deer a
So- Okay,
Oh my god.
guys, side comments. Let's bring it back in, please.
You
Thank you.
said shadows and I just started singing. I still see the shadows in my I believe you're
Okay.
Oh, stop walking. Sorry.
Side comments need to end. That does not mean you're
Hate
going.
Wednesdays.
Yeah, as long as you go and have another.
Hey, go to you.
I'm going to the counselor.
Fine.
When they start making fun of me, I'll go.
Okay.
They start bullying me.
Guys start making fun of them. Hey, so
Ew, you're so ugly.
Randall, you look like the dude from that one
Randall, your hair looks like a rat's nest.
okay, guys, let's go
You know
back
the
out.
dude from,
Let's go to out.
what's it called?
Ratatouille,
No,
that's
no,
what you look
no,
like.
no.
You know the dude from,
Okay, no.
No, we don't
From,
know that one dude.
you know, oh my gosh, it's that one movie, and
Hey,
Yeah,
can
that
we
one.
play the
Oh
quiet
yeah,
game?
that one.
You already lost.
Hey, that's a great idea.
Quiet game.
Okay,
That
guys, quiet
includes you.
down.
Starting now.
Okay, awesome, thank you. So,
Nathan's out.
You guys are so freaking childish.
okay, so we're gonna measure the tree shadow, and at the same time of day, measure the shadow cast by a meter stick that we hold at a right angle to the ground. Find the height of a tree. Here's how this is gonna be able to work, okay? Thank you. So, here's how this is gonna work. What kind of angle would a palm tree make with the ground? It would make a right angle, okay? If you go to like the center of the tree, it would make a right angle with the ground. Voice is off. It would make a right angle with the ground. So what kind of angle would I have to hold the meter stick to the ground at? A right angle as well, and it kind of shows that in there. Now, if the shadow is coming from the sun, it's coming from the sun, right? And if you do it at the same time of day, is the angle it's hitting the object at, whether it's the tree or the stick, is that really going to be much different? No, it will not be, okay? And especially if they're closer together. As you go further and further apart, the angle is going to be slightly, just very minutely, meaning very, very small amount, different. And that's just because the Earth curves, because it's not flat, okay? No comments on that, please. Thank you. So, these angles are going to be congruent as well. No, this is not flat. I said no comments on that as well. So, Kennedy. Thank you. Thank you. So, we can prove these triangles similar by what method?
Indirect measurement.
No. It's something from 4.7. We had 3 shortcuts to prove triangles similar.
ASA.
No.
Angle, similarity.
Angle, similarity. We have 2 sets of angles that are congruent to each other. So we can prove these triangles similar by angle, similarity, right? Okay. So if we know the triangles are similar, we can use properties of these similar triangles to measure this height of the palm tree. How we're going to do this is we would say the length of this shadow to the height of the palm tree is going to be proportional to the length of this shadow of the meter stick compared to the height of the meter stick. And we can do this to figure out what it would be. Alicia, we're going to be setting up a proportion. Do you have an idea of what it might be? Okay, go ahead, Alicia.
1.6 over 7.2 equals 1 over x.
Awesome, that'd be great. We could set it up a few different ways, and this could be one of them. We could do the length of the shadow of the meter stick, our small triangle, over the length of the shadow of our palm tree, the big triangle. So it's shadow over shadow, small over big. And then we match it because we did small over big. We have to do the height of the small triangle from 1 meter for our meter stick over the height of the palm tree, which we don't know, which is why we're trying to do this, which is x. Any question or method?
Question.
Okay.
Okay. So if it's 1.6 over 7.2, and like those are 2 different things, and mine is x over or 1 over x, because those are on the same side. Oh wait, no, I'm just kidding.
Okay. What? So, do we know what 1.6 over 7.2 is off the top of our head? Probably not, but we can use a calculator, right? Okay, Max, what'd you get in your calculator? 4.5. So we can say 4.5 is going to be equal to 1 over x. Now, could we also have just done cross multiplication and go from here? That might be a little easier for us. That might be more normal. Okay. Cross multiply. What's 1.6 times x? 1.6x. What's 7.2 times 1? 7.2. What would we do now? Divide.
That should be 1.
X will equal, this is where we get that,
Calculator
7.2 divided by 1.6. That's where we end up getting 4.5. So what's the height of this palm tree? 4.5 meters. 4.5 meters. Very good. I heard someone say meters. Okay, 4.5 meters. Be approximately 15 feet. Just based on the tree. Kind of crazy the Augusta creates. Now this is something that can be used to measure the height of a lot of different things. That would be straight up and down. So like I said, you use this for the Empire State Building. You go to New York, be in the Empire State Building, and if you do it at the same time of day, you can measure the length of the shadow of a meter stick, or the shadow of a person if you know their height, and the shadow of the Empire State Building, and set up this problem and find the height. It would work. Kind of cool, but it could work. Why would you have to do it at the same time of day? Lizzie? So the sun is at the same angle, the same place. place, okay? Because if you do it at different times of the day, the shadow is different lengths, right? If you do it like noon, your shadow is really just right beneath you, isn't it? Just about. Okay, maybe not exactly, but just about. Whereas if you do it different parts of the day, it's either longer and further away from you, or shorter and closer to you and on different sides. So you want to do it at the same time of day, so that way it's consistent. It keeps these angles the same. It keeps the triangle similar. Let's go on to the next example, which is really doing the same method. Okay, this indirect measurement is really just using or utilizing our 4.6 knowledge. Example 2, Sid is 72 inches tall. 72 inches, how many feet is that?
It's 3 feet.
Nope.
4
Oh,
feet.
6 feet, exactly. Sid is 6 feet tall, 72 inches tall. To measure a flagpole, Sid stands near that flag. Sid's friend Miranda measures the length of Sid's shadow and the flagpole shadow. Find the height of the flagpole. So once again, if it's at the same time and they're near each other, then the angle from the sun is going to be the same for these triangles. And a person would be standing at a right angle with the ground, and a flagpole would be at a right angle to the ground, right? You'd sure hope so, at least. So then these triangles could be similar once again. Excuse me. So what kind of proportion could we set up to try and find the height of this flagpole? Abby.
128 over 48. And then x over
48.
Hey, that's a good question. Okay, yes you may. So that's a good question. First, I want to talk about what Abby said, then I'll talk about what Nathan said. Abby said 128 over 48, and x over 72, okay? So if you have 128 over 48, 128 is the length of the shadow of the flagpole, big triangle, over the length of the shadow of the person, Sid, small triangle. So big over small, shadow over shadow. Then we have to go big height of the flagpole, which we call x or h. Abby's looking at x, that's perfectly fine. Keep calling it h2. Over the height of Sid, small triangle 72. Nathan asked, hey, could we do 48 over 128 and 72 over x? Yes, we can. I see Max nodding his head. Yes, we can. We can do small over big and small over big. That's fine. Switch one, we have to switch the other. Either way, it'll be fine. We'll get the same answer. How do we go about solving this now? Cross multiply. 128 times 72 and 48 times x. Let's start with the easy one. 48 times x. 48x. Okay. This next one, somebody have your calculator ready.
9,200.
How did I get 100? Oh, I divided. Or something.
9,216?
No.
Yes.
How did I get 896?
Divide by 48 would be 3,000.
128. Oh, not. Oh, yeah.
Good luck. Okay. Did people verify this 9,216?
Yeah.
Okay. How do we solve now?
I got it.
Nathan?
Divide by 48.
I
3,456.
no, I disagree with you.
192.
What?
JK.
Yeah.
I don't know.
Jimmy.
9, 2, 1, 6, 5,
Okay.
Yeah.
I don't know. I
Is
got
that what I said?
Yeah.
Oh.
Okay, so it'd be 192 inches. That would be the height of our flagpole. We would need to call it inches, okay? It's not talking about 192 zebras or 192 rhinoceri. Is that
What's a rhinoceros?
I think it's just rhinoceros.
Yeah.
It's rhinoceros.
I think it's just rhinoceros.
But it's
But
harder to say that.
it's fun to say rhinoceri.
I can't even
But-
say that.
Rhinoceri?
I can't even say that.
Say it.
No. Make fun of myself.
Rhinoceros?
Okay. Anyway,
Oh.
questions?
R's in there.
Questions on this? How we got this? Okay, is this any new math to us?
No.
No, it's all stuff we've done. Okay? It might be easy to you, it might not be easy to you, but it's math we've done before. It's not new math to us, but it's math we're continuing to refine.
The plural is rhinoceroses.
I'm getting
Okay.
a box from.
Get that little walk around thing again.
Not right now.
Okay.
Finding an unknown distance. So at the bottom of your page, kind of the last third of your page here, finding an unknown distance. In real world situations, You might not be able to measure an object directly because there is a physical barrier separating you from the object. We can use similar triangles still in these situations as well. Similar triangles can help us out with these things. So a hiker wants to find the distance across a canyon. Distance across the canyon, which we're going to call D. She locates the points as detailed in the picture below. So you know this is 327, this is 600, this is 400, and this is D. Do we know that these triangles are similar?
No.
No, why not?
I don't know. Nobody's answering.
Okay. I don't think we have enough information to know quite yet. Max, what do you think?
We know they're similar.
How do we know they're similar?
They're vertical angles.
What's vertical angles?
The two are touching, so those are two.
Okay.
No.
Angle WZV.
Those are similar, so you can angle.
Okay. So Max is saying, hey, angle WZV and angle XZY are what we call vertical angles. They share a vertex, they're opposite each other, and their sides make an X. So they are always 100% of the time congruent. Vertical angles are. So now Max is saying, we know that these triangles are similar by angle-angle similarity. They both have the right angle, and they both have these vertical angles that are congruent. Angle-angle similarity kicks in. Now we know the triangles are similar. What can we do with similar triangles and the knowledge that we're given? We can do the fraction thing. What do we call the fraction thing? A proportion. Thank you. Okay. At least you know what you're talking about with the fraction thing, though. Okay. So raise your hand if you can help me set up this proportion. Nick and Manavi, help me out with this one.
400 over 600
Okay.
equals D over 327.
Awesome. That'd be one way we could do it. Are there other ways we could set it up?
Yep.
Yes, there are, but this is one way we could do it. We could do 400 over 600, small over big.
That's what.
And then you'd have to do small over big as well, D over the corresponding one, 327. You can reduce it. You can reduce it before you cross multiply. What are you saying that you can reduce, Alicia? Okay. 400 over 600. What could that reduce to?
Something. Divided by 100.
Okay, divided by 100. If you divide by 100, that's basically like you just cross over the zeros. Thank you so much. Okay, and then you divide 4 over 6 again by 2. And so you can make this 2 over 3 is equal to D over 327. That might make our math a little bit easier.
Okay, now can we cross?
Now you can cross multiply before or you can cross multiply now. You get the same thing either way as long as you do your math correctly.
3D.
So 3 times D is 3D like the movies. And 2 times 327 is
654.
654. Oh, okay. You'll get the same answer. You'll see it.
You got us.
Now, how would we solve? Randall? 3D is equal to 654. How do we get D by itself? Divide.
I got 2.
D is equal to 218. That sounds good to me. 218 what? Feet. You want to highlight that that is feet. 218. Questions on this? Okay, Kennedy, what doesn't make any sense? Okay, what part of the math? Okay, did you understand our initial setup? Okay, so did you understand our simplification going from 400 over 600 to 2 over 3?
Who was on last?
Okay, so we said, hey, 400 over 600, we can divide those. So we first divided by 100. 400 divided by 100 is 4. So we made this 4 over 6. So this becomes 4 over 6, basically.
This is what makes me.
Okay? Does that make sense, Kennedy? Are you just saying that? 400 over 600. 400 over 600. We can divide 400 by 100 and get 4. 600 by 100 and get 6. So then we said, hey, we can reduce 4 over 6 to 2 over 3. So we did that and kept this D over 327. Does that make sense? Okay. Then from there, cross multiply. solve for D. Probably bet D. And then you got 3D is equal to 684. Does that make sense? Okay. And then from there, divide by 3, you get our answer. Awesome. Good. Okay, hey, on this last one, here's what we're going to do with the last one, okay? Flip to it real quick. Okay, hey, up, boom! Gone. Get wrecked.
Get
Bro.
wrecked.
Oh, man, look at the top of your head.
Spam GG.
We are going to have homework, okay? Here's what we're going to do, class. We're going to do some work time for the homework, okay? We have quite a bit of class time left, which is awesome. So what we're going to do is we're going to use a good amount of that for homework time right now. And then, girls, listen up. And then we're going to start our new notes for just a little bit, okay? But we're going to use most of this time for homework time. So I'm going to pass out the homework right now. I tired of Mr. Costle.
Oh.
Please? Yes. So please wait until I pass it out.
Here you go, Kylie.
Give it instructions.
Got him. She got you. Yeah,
After I
she got you.
Good. Okay, so my instruction for this class, my instruction for this is a don't do. Don't do
All of it.
jota jota jota.
It's hot, it's jaw, jaw, jaw.
It's hot. It's still hot.
Okay, so jota jota jota. We're not gonna do numbers. I believe I have 10 and 12. Let me double check that.
Such a nice guy.
What do you think? So I like to think so.
Ain't 11 and 12?
No, 10 and 12.
I tried.
I mean, I don't do
So we're not gonna do numbers 10 and 12, okay? Hey, here's what we're gonna do. So we have about a little over 40 minutes, about 42 minutes left of class, okay? You guys can listen to music in a second, so I just want to give you guys instructions on what we're going to do. So we're gonna work on this for about, let's give it about 25, 30-ish minutes. So let's plan on going till about 1:15, and we'll check